Here is question number 31. A particle of mass m at rest explodes into two parts, capital A and capital B, having masses m and 2m respectively. The ratio of De Broglie wavelength of part A and part B will be what? Now, the momentum of the particle will be conserved here. So, according to law of conservation of momentum, the initial momentum before explosion will be equal to the final momentum after explosion. Initially, it was at rest, so Pi you can write 0. Finally, two particles you have. Momentum of particle 1 is P1, momentum of particle 2 is P2. So, from this relation, we can say that the magnitude of momentum of particle 1 and particle 2 is absolutely equal. Now, we know very well, according to De Broglie wavelength, lambda is given by h by p. Now, if their momentum is equal, then their wavelength will also be equal. Therefore, lambda 1 must be equal to lambda 2. Or you can say the ratio of lambda 1 is to lambda 2. We'll write 1 is to 1 as they are equal. So, after looking at the answer, we can say that option number 3 is absolutely correct. We'll go with option number 3. Now, let's move on to the next question, that is question number 32. Here is question number 32. A graph of cutoff potential V0 versus frequency F for same intensity of light for metal plate A and B shown in figure. Choose the correct statement. Now, here the question belongs to the topic photoelectric effect, and here the graph is plotted between cutoff potential versus frequency. This is the graph of cutoff potential versus frequency for any metal surface V0. Here, this particular point is known as threshold frequency F0. Now, the threshold frequency for A, we will write F0A, and threshold frequency for B, we will write F0B. According to the graph, it is clear that F0A is less than F0B. Therefore, work function, that is H into threshold frequency, so HF0A will be less than H of F0B. Means work function for A is less than work function for B. So now let us check the options. Work function of metal A is greater than the work function of metal B. Goes wrong. Option number 2. Work function of metal A is less than work function of metal B. Absolutely correct. We have proved it. So we'll go with option number 2. Now let us proceed to the next question. That is question number 33. Here is question number 33. In photoelectric effect, the electrons are ejected from metals if the incident light has wavelength less than certain maximum. What? Now, we know very well in photoelectric effect, the energy of incident light must be greater or equal to the work function, the minimum energy required to eject the electrons from the metal surface. Now, this E is energy of incident light, which is given as Hc by lambda, where lambda is the wavelength of incident light, must be greater than. Phi is what? Hc by lambda naught, where lambda naught is threshold wavelength. Hc will cancel out. Now, from here we can say that the wavelength of incident light must be less or equal to wavelength of or threshold wavelength. So, this lambda must be less than or equal to the threshold wavelength. So, according to question, if the incident light has wavelength less than certain maximum, so maximum wavelength lambda max must be what? Lambda naught. We cannot use a light having wavelength more than lambda naught. Otherwise, electron will not eject. So that's why after looking at the options, we can say that option number 1 is absolutely correct. Now let us proceed to the next question, that is question number 33. If the kinetic energy of proton gets doubled, then the De Broglie wavelength associated with it change by what factor? Now we know that the De Broglie wavelength lambda is given by h by mv. And we know very well the momentum associated with kinetic energy k is as P square equals 2mk, where m is the mass, k is the kinetic energy. We can write P as under root 2mk. Now the D wavelength in terms of kinetic energy is given by h by under root 2mk. If we change the kinetic energy, or if we make the kinetic energy double, then the momentum will change, given by lambda dash, which is h by under root 2m into 2k, because the kinetic energy is doubled. So here this can be further written as h upon under root 2 times under root 2mk, which is equal to 1 by root 2 times lambda. So wavelength is changed by a factor 1 upon root 2. So that's why we'll go with option number 4, which is absolutely correct. Now let us proceed to the next question, that is question number 35. So here is question number 35. The De Broglie wavelength of particle accelerated with 100 volt potential difference is 10 to the power minus 9 meter. The De Broglie wavelength of the particle, if it is accelerated by 1600 volt potential difference, will be what? Now we know that here in this case, the charged particle is accelerated by a potential difference V, then its kinetic energy can be given as charge into potential difference. And according to De Broglie hypothesis, lambda, De Broglie wavelength, is given by h upon under root 2m into kinetic energy, which we have already taken Q into V. So therefore we can say that the lambda is directly proportional to 1 upon under root of V, because the rest of the things are constant. Now initially it was lambda 1 proportional to 1 upon under root V1. Finally it is lambda 2 proportional to 1 upon under root V2. Taking the ratios, we get lambda 1 upon lambda 2 equals under root of V2 upon V1. Now let's plug the values from the question in given expression. We will get under root. V2 is 1600, V1 is 100. Cancel out. Ultimately, we will get lambda 1 equals 4 times lambda 2, or lambda 2 as lambda 1 by 4. That is 10 to the power minus 9 by 4. And after solving, we will get the new wavelength lambda 2 as 2.5 angstrom. So this is our final answer, and after looking at options, we can say that option number 2 is absolutely correct. So we will go with option number 2. Now let us proceed to the next question, that is question number 36.